Then we have Damien Duportal here. He is a trained engineer at CloudBees. And he will talk about tales of training, scaling CodeLabs with Swarm mode and Docker Compose. Please welcome Damien.
Hey, hello everyone. First of all, our Docker selfie, if you don't mind, just to have a proof to my boss that I was there. Okay, everyone, cheers. Thank you very much. So, welcome. So, we are here to talk about a trench story. What you will hear is just a tiny story on something I tried with Docker Swarm Stack. It's not about tooling wars. I don't care about those things, and I won't have time to show you code, but help yourself. Everything is on GitHub, it's open, so if you want to see a recipe, you can talk to me or dig yourself on GitHub. So, the main thing to have in mind is I try to drink my own champagne. This means, as a training engineer, I had to learn myself to be able to make people learn. That's very important. That's the main takeaway of that session. And so you should. By mentoring people, you will learn a lot. Second takeaway is that you have to focus on building something that first works and then iterate to improve. This will help you to not feeling very tiny regarding to the lot of tools and things we can do in our lives. So, what is a CodeLab? It's an hands-on. It's a workshop. It's a part of a training where you have to do things. Depending on people, some people want to read, and some people want to just see or watch or do themselves. So the CodeLab here refers to a practical exercise about one application, one language, one framework, whatever. It's an isolated environment dedicated to a single person. A CodeLab, when you run a training session, a meetup, practical exercise, you have to consider that CodeLab as a production environment. You will have network problem, and if you don't, you will have slow network. You will have a configuration diversity. In that case, that means nightmare from Windows 7 with Kaspersky machines and corporate proxy to the custom-made OpenBSD with Dvorak keyboard. So you will have every configuration you can dream or have nightmare about. You will have user errors because people are learning, they try things, they break things. That's sane, that's normal. You cannot do without that. So it's like in production. Your user have behavior that you don't want, but they have it. You have to deal with it. Finally, it's time-boxed session. You have 1, 2, 3 hours, but you don't have 2, 3 days. You don't have all the time. So it's like having peak events. At the moment, you have a big load on the machine hosting your CodeLabs. So in my case, I don't want to have that, but it's a Jenkins training. So I had to provide for each CodeLab a big set of technologies, from Jenkins using Java, Python application for command line, and whatever services. So this collection of technology, we don't care, it's just tools. The important thing here is that it has to be defined by a service list in an explicit way. That's why I try to use Docker Compose for that. Because on just one file, I can see all the services. I don't have to care if it's Python, Go, Java, whatever. I have one way of high-level definition of what I want to provide to the attendees. The second challenge to solve is the portability. I want this to work as well on my tiny city in South Belgium, where we don't have internet in the room where we do trainings, as well as Jenkins World, which is a conference like this one in San Francisco, where we have awesome internet Wi-Fi. It has to work everywhere. Finally, I want explicit definition on all the layers, not only the services, but also on the low levels, to be able to share that material with everyone who wants to use it, or everyone who wants to maintain it with me. So everything has code. So here is my first implementation that I use as a daily thing on my work currently. It's virtual machine-based workload. Each trainee have its own virtual machine dedicated for that person. where I have to maintain an host OS, Docker and Compose installation, a console agent, I will explain why is it there, and all my stack. So I am the blue person, and as a trainer, I have to connect on SSH to a bastion for security. It's just a server where I bounce on my infrastructure, and I have to deploy using a nice tool named Terraform, which provides infrastructure as a code shared in a GitHub repository. The end user goes through a load balancer, and each time we start a VM, it will declare itself on console server that will reconfigure the reverse proxy. Boom, magic. So me, when I want 12 instances, I just put 12 on a text file. I type Terraform apply, and boom, I have 12 instances. Everyone here can do this. That's very easy. Just try it, really. So the takeaway of that first version was it worked. It's been 1.5 years and it works. That's a very good takeaway, I would say. The second is that it's very easy to begin with and to operate. It's complicated to deep dive, but when I have a new trainer, I say, add 2 lines there, the number and the name of the session, Terraform apply, and it works. So I can delegate that to an automated system or whatever. Main problem is the cost. 1 person per VM. It costs a lot. It's not something we can afford personally. My company can for professional, but when I'm alone on a local meetup, I cannot afford that. Second thing, since my boss hates the acronym, I just put one for him there, it's time to play. When you see a bug on your training, everyone has a bug when you are writing a new training, a new exercise. The time to have this deployed to your training is on the order of magnitude of 10 minutes. Time to rebuild the VM, deploy the VM on MOS, and deploy the new classes. So this was one of my main problems. That's where it's a standard Docker pattern. That's the road to native orchestration. At that moment, Docker Swarm mode was announced, and I say, oh, it's been a long time, I should learn that Swarm mode, so let's try it in production directly on my training CodeLabs. So first goal is solving cost issue by using the Docker Swarm or any container orchestrator to put more people per virtual machines. The second thing is that I wanted to solve that time, so I want something that starts very quickly. If you haven't tried play with Docker, you should. You click, and in a few seconds, you have a complete Docker host OS. And in less than 10 seconds, you can have a working Swarm cluster. So the main key here is that I had to untie infrastructure providing any new resources from the service things. Me, I had machines because I have the right on the clouds, and my trainers or colleagues or people that want to give a training with my tooling just have to do the same. 2 lines, 1 command, and it starts in a few seconds without needing any cloud access authorization. They don't have to create machines, but services. So that's basic pattern, in fact. Everyone has this one with Docker. So as an admin, I just have to use Terraform for deploying my cluster. It's just a series of machines. And then all my trainers are able to just push new instances. I have a class for Jenkins, a class for Docker, a class for whatever. I've put the infra admin because a lot of the sidekick services monitoring are just containers as well. Everything is in containers. Nothing runs on the machines. That's the main change. And then, boom, benefits. My user don't see the difference. They access on that cluster. I had reverse proxy, whatever. In fact, we don't care. That's easy. They access and they have their machine as in the step 1. One positive side effect I learned on that, it's that by relying on the Docker ecosystem, I had so much tool that I just remove entire pieces of what I did before. Less code, less effort. That's the maturity in IT. You delete code, you don't have to maintain that, and it just works. So you can care on something more valuable. Finally, that valuable, more valuable things, those are the nice problem I had with that infrastructure. And I would say it's first world problem. When you have those problems, you're done, because those are the core value of my CodeLabs. First, I have to focus on the pattern, on the monitoring and resource management. Scaling pattern, it's easy. I had to solve a tiny problem. Instead of having a full stack scaled horizontally per layer, like you just want to scale your middleware or your database or your front or whatever, I had to deploy n times the same thing. So this is not what Docker Stack does by default. It's a single stack. So I had to build some script stuff to do Docker Stack with one variable. We don't care about the solution. It's just a pattern. It was my main and core problem, and I solved it quickly because I had to focus on this first. I don't have to focus on tooling. Monitoring metrics, it's a false problem. I should have done that at the first time. I'm teaching how to do CI/CD, feedback loop. Where was my feedback loop at the first step? I need measurements to say, if I change something, this should have a gain. And I have to close that feedback loop and iterate. If you don't have that, you're dead. Again, I won't provide a solution. I found at least 7 working solutions out of the box in less than 10 lines. So I put the first that was working, and I don't care. I have a nice graph and metrics, and I don't care. The main interesting one is the cost-based driven one. It's the resource management. The thing is that with a virtual machine, I had one stack of services, the big one you saw at the beginning, that I have to compete for only the virtual machine resources. So 4 gigabytes, even Jenkins can run on 4 gigabytes. But when moving to control workload, my gain was to distribute the cost and all the activity. So the concern was competing, n services competing for n pack of resources on virtual machines. So what happened the first time, all my Jenkins machines were constantly restarting because killed in the head by the memory killer. Because, yeah, the orchestrator might not be deterministic. So sometimes I had too much workload. It started gently, and then Java, start to use a lot of memory and then release that memory. So in order to address that, I basically just automated the whole labs, and then I run those automation tests. If I say, hey, create that repository, do this, run that build, and see that page, I automated that with single shell script. And I use my measurement system to say, oh, I see that at that moment in the training, after 10 minutes exercise 3, instruction 4, I had a memory peak on Jenkins. So based on that, I was able to say, oh, this is the max memory I need. I have my limits. So I can just say limiting, and now I have something stable and more deterministic. So then I can say, okay, I need twice more machines or twice more memory, but it was fixed and known due to the feedback loop closed. That's why you need it when you move to container. Is it a problem? That's a nice problem to have, because this is directly your cost here. And you're not focusing about Kubernetes versus Swarm or whatever versus whatever. You focus on the things that matter, thanks to the Docker tool. Summarize of the takeaways of that second iteration. It's still working. We gave a training, and it worked. People don't see any incident, even if still restart happens. It was easier than I thought before. I should have done that first, not focusing on console or whatever. Those are very good tools, but for simple use case, don't try to reinvent the wheel. You have a lot of things that just work, that are easy to go. Docker, Swarm, even Kubernetes are things easy to start with. Cost, big win. Instead of 1 person per virtual machine before, I was able to pack 4 persons. So cost directly divided by 4. That's good order of magnitude. The time to play, to deploy a complete class, almost 10 seconds instead of 10 minutes. I let you imagine when you have an error, acceptance testing or whatever, when you want to iterate on that. And finally, code maturity. 5 tools to maintain instead of 8 originally. So, next step, I wanted to try Kubernetes to solve my pattern problem. I think with today's announcement, I don't have to speak about that. It will just work, and it will solve my problem again without doing anything. So, thank you very much for that. Thank you very much for your attention, everyone. One last message. I have one last message. I learned something, and it's very difficult for me to transmit by writing, but I transmit that to you. You all have a story to tell about Docker and what you do. So go on your local meetups or with your colleagues or on a university and share your knowledge or what you did with Docker or even what you failed to do with Docker. Really, that's the community thing. I encourage you to do, mentor someone or to share your experience. You all have something to tell to the others. Thank you very much.